So yeah, so arc means inverse. So down here, the little table, the range, that's kind of what we're looking for, the range of what values do we look for, right? What values do we look for here? What rate, sorry, is that angle? Yeah, what angles do we look for, right? So if we're trying to find inverse sine, we're only focused on negative pi over 2 to pi over 2. We're only focused on that window. If we're doing arc cosine, we're focused on 0 to pi. Are those important for what we're doing? No. That's more of a math 3 thing, but I just want to throw those out there. Because if I'm looking for sine, inverse sine at 0, I go to my chart, you see I could have 0 pi, I could have pi, I could have 2 pi, I could have 3 pi, 4 pi. I can keep going, right? Because the sine wave just keeps going and going and going. So do I have to list all of those? No. You just have to list the ones from negative pi over 2 to pi over 2. That's only 0. So you'd only have to list 0. We wouldn't have to list all of them who have 0 as a ratio. Okay? So that's where that comes from. That's where that kind of helps us there. But like I said, we not really, I just threw this on there just because it's kind of background, but it's not necessarily important for finding derivatives. Okay, so let's look at 3a. Okay, so inverse, we know it's inverse cosine, right? Because it says. So we go to our little table up here, and we see inverse cosine, right? -1 times, it's really -1 times the derivative of u over the square root of 1 minus u squared. Okay? U is what's inside the parentheses. U is what's inside the parentheses. So in this case, that's u. Right? That's u. Okay? So let's follow what it says. So it says -1 times u prime. Okay? So -1 times u prime. Well, if u is x squared, derivative is 2x. That goes on top. The bottom is this guy. Square root of 1 minus u squared. Square root 1 minus u squared. And we said x squared was u, right? Simplify it. You get -2x over the square root of 1 minus x squared squared is just x to the 4th. Done. Okay, plug it in, simplify, that's it. It's not too bad. Like I said, the only hard part is if you don't have these in front of you. Okay, so is it going to be a big part of the test? No, like I said, out of these whole sets of notes, you'll probably have one question on your multiple choice that either talks about this or talks about one of these guys. Okay? But again, if it's a 40 question test, not a big deal. Nothing, like when we start reviewing for the AP test, this is probably one of the ones we won't review because it's only maybe one question out of 40, 35 multiple choice questions, right? But our next test is probably going to be 6 or 7 multiple choice questions because it's only a chapter, okay? So that's 1 out of 6 or 7. That's a little more important. So this one, I would probably, like I said, I'd probably put this red box on my notes card somewhere, okay? Okay, so the next one, inverse sine, okay? Well, first thing we're going to do is rewrite it, just like we always do. Okay. So u is now this guy. right? Because this was, they didn't put parentheses, but essentially that's what parentheses were. Okay? So the square root of 2x. Okay, so let's go up to, or just look up sine. Okay, it says u squared over square root. So the bottom's going to be the same. If you look at the bottom, the denominator is the same as cosine. Right? You'll notice some of these are the same. Tangent, cotangent, very similar. Cosecant and secant, very similar. They're all very, very similar. Okay? So let's see, so square root. Okay. So to do the derivative for u, we need to use power, or the chain rule. So we have 1/2 2x to the negative 1/2 times the derivative of the inside, which is 2. The bottom is 1 minus u squared. And again, u is 2x to the 1/2 power. Okay, so simplify. That's the derivative. So simplify. Well, I can multiply this guy times this guy to make 1. So I have 2x negative 1/2 power over the square root of 1 minus, so if I distribute the powers, it's going to be 1/2 times 2, which is 1. So it'll be 2x to the 1 power. Okay, clean it up a little bit. So the bottom is 1 minus 2x. You don't need the parentheses anymore because it's the first power. The top is a negative power, so I'm going to move that to the bottom. I'm going to give it back its root as well. And then you leave 1 on top. Okay? You can multiply the powers and do that, but I'm not worried about that right now because we're just worried about the derivatives. So is that the perfect, most simplified answer? No. But it's the derivative. All I'm focused on is the derivative for today. Yeah, if I wanted to simplify it, you would multiply the roots to get rid of the root. But like I said, I'm not worried about that right now. Like you would, if you're curious, you would do this. You'd combine the roots and you'd say 2x, 1 minus 2x, and then you'd do that. And then you distribute and go on from there. Okay? But like I said, I'm not really worried about that today because we're just finding derivatives. Okay? All right, 2 more. 2 more, and then you guys can get started in practice. So as you've noticed, the 2 most common are sine and cosine. Will you have a tangent? Will you have a cotangent, secant, cosecant? Yeah, but they don't show up very often. So the ones that you're more likely to see are sine and cosine. Okay? Okay, so here we go. This one's mixing rules now. So here we go. We have x times the inverse of x, right? That's times. Okay. Plus, right? So there's 2 terms here. We have 2 terms here. So we need to find derivative of the first term and then derivative of the second term. So our first term is right here. Second term is right here. So we got to find the derivative of the green and then derivative of the magenta and put them together. Okay? So the first thing I'm going to do is I'm going to find the derivative of the green. What am I going to use to find the derivative of the green? Product rule. Very good. Very good. Product rule. Okay? Product rule says the first times the derivative of the second. Well, the derivative of inverse sine we have on the other page. It's right there. We just used it. U prime over square root of 1 minus u squared. Okay, so for this guy, what is going to be considered u? X. That's it, just x, right? So what's the derivative of u? 1. 1 minus x squared plus. Now the opposite, the derivative of x, 1 times the second. Okay, so this is the derivative of that guy there. Okay, so now let's do the derivative of this guy. Well, it's got a root, so I got to change it. Okay, so I'm going to change this guy to not have a root, so 1 minus x squared to the 1/2 power. Okay, so chain rule. One minus x squared to the negative 1/2 times the derivative of the inside, which is negative 2x. Okay, clean it up a little bit. So that's the derivative. Like I said, that is the derivative. But again, if it's on a multiple choice test, that answer is not going to be there because we got to clean it up a little bit. So the first one, I would just put x on top, the first term. The second term is just the inverse of sine. The last term is also going to be a fraction. So I'm going to multiply this guy times this guy, and I'm going to get negative 1, negative 1x. And then this guy, I'm going to move to the bottom. 1 minus x squared. Again, I'm done with the derivative. Derivative's done. But if this is going to be on a multiple choice test, that answer that I got here, oops, should be y prime, is not going to be there. Okay? So how would you clean it up? Well, this is our first step. How would I simplify it even further? Yeah, which one cancels out? Yeah, this guy and this guy will completely cancel out because they're opposites of each other. And if you add opposites of each other, by definition, they go away. So its derivative is just the inverse sine, or arc sine. Okay. All right, one more, and then I'll let you guys get to it. So arc secant, one we haven't done yet. Again, it always has a u. Always has a u, even if it's just x. This u is going to be 5s. So they're using s instead of x. Okay? So arc secant says u prime on top. All of these are fractions. All of these become fractions. So u prime, the derivative of u, is just going to be 5. And then it has, this guy has some bars. All right, this guy has some bars. It says u inside the bars. So that's 5s. And then our square root. It says u squared minus 1. Okay. So let's simplify it a little bit. You can simplify it a little bit. What do the bars mean? So what are those bars, those lines on the outsides of 5s? What do those mean? Absolute value. When do those matter? When do absolute value, when do we need absolute value and when do we not need? So when do they matter?
If it's positive or negative.
There you go, right? If it's negative, really, if it's negative, right? If you put a number inside absolute value and it's positive, is it going to change? No. If you put a number and it's negative inside absolute value, is it going to change? No. So the only time it changes is when 5s, or when you plug in something for s that's negative, right? So if I'm going to plug in something positive for s, it doesn't matter. You don't have to have them. So why is it, sometimes you'll see the bars there, sometimes you won't see the bars there. You're like, why sometimes and why not? It depends what you're plugging in, okay? If you're going to plug in a positive number, you don't need them. If you're going to plug in a negative number, then you need them, okay? So sometimes they'll be there, sometimes they won't. That's why. So for right now, let's just keep them, since our definition says that. And then 5s squared is 25s squared. Oh wait, before that, I had a student who did this. Can you do this?
Oh.
They went from the top to the bottom. Can we do that?
No.
No, why not? But it's squared, right? 20.
Minus 1, isn't it?
Yeah, right. This is actually difference of squares. So if students see 25s squared, the square root is 5s minus 1. The derivative is 1. Can I just write 5s minus 1 without? No, because that's not what it means. It means this. It's difference of squares, right? 5s plus 1, 5s minus 1. By rule, we can take things out of the square root if they are exactly the same. We can take out pairs. These guys aren't pairs. One's a positive, one's a negative, okay? So we can't simplify that. So don't get tempted to do that because it doesn't work, okay? That's as far as we can go. All right? Like I said, these are very, I don't want to say easy, but they're not hard. They're definitely not hard. But as long as you have access to these guys here, to the red, okay? So like I said, guarantee you there's going to be one question from these notes on the multiple choice. That's it. One question from the multiple choice. Do you want to get that question right, or do you want to get that question wrong? It's up to you. If you want to get the question right, I would suggest putting this on your note card next time. Okay? If you can memorize all of them, which I suggest don't do, because when you memorize things, other things fall out of your brain, right? The only things that don't fall out of your brain are long-term memory things. You just learn this. We have the test next week. Yeah, end of next week we have the test. That's short-term memory, okay? So don't, just a word of advice, don't try to memorize. Okay, yeah. As I was saying before, we multiply by the 2. Don't forget to multiply by the 2.
I was wondering.
There you go. Can you cancel out the 10 and the 5? Yes, but you want to be careful because we don't know what number they're plugging in for s. If we knew what number they were plugging in for s, go for it. If it's positive, go for it. But we don't know which number, so be careful with that, so leave it like that, yeah.
Okay.
Okay? All right.